and welcome to Geography Rocks. Now, as you know, we've been looking at resource management. Before watching this YouTube clip, you should have watched the films on resource management. You should have downloaded and printed out the resource management booklet that was sent to you via email. If you're unable to print out that booklet, it is long, don't worry, just use some paper and take some notes. Also, please bear in mind that this is part 2 of the booklet. There are 2 supplementary films that come before this to help support you with part 1 of the booklet. So making sure that you're in the right place to be watching this film, you will need today either some lined paper and a pen or the resource management booklet if you've been able to print it out. You should have Caboodle out on your screen or a revision guide in front of you. Ideally, you should have read the resource management section from Caboodle to help support your understanding of the questions that will be coming up in this PowerPoint. Okay, once you've got everything ready, and maybe even a cup of tea, let's get started. So the first question here is about energy management. It says it's optional, but we may as well have a go. So it's question 6 in section C. This is the one that you're going to answer because we are going to be answering the question on energy in the main exam. So focusing on energy is really important for your revision. The question says, using map A, page 288, which you can find on Caboodle, there's a smaller copy at the bottom of this slide, explain the global energy consumption and global energy supply. Look for countries where it is high and low and what the reasons are for this. So the map that I've given you is just of energy consumption. In Caboodle, you've also got the supply. Let's take a look at it. There are high consumptions in HICs. Remember, these are high income countries. So if we look, for example, at Australia, the United States of America, parts of Europe there, if you look at Spain, France, Germany, you can see quite clearly that they're using high levels of consumption of energy. They've given examples here of the USA, Canada, Australia, Saudi Arabia. You can see that they're using over 5,001 and more kilograms of oil equivalent. So using huge amounts of oil. Okay, let's move on. It will take a moment for you to draw a diagram like this if you haven't got the revision book. And it says there to use the mind map below to identify the factors that affect energy supply. If you need to, pause the tape now and just draw down a mind map similar to this one. If you've got the booklet, then you can take a moment to collate your ideas and jot down some notes into each of the boxes. So pause the video now. Okay, welcome back. So we need to think about factors that affect energy supply, and the first box there is about political factors. Political factors could include things such as conflict. There may be conflict between countries which could make getting fuel or resources from one place to another across a border really quite difficult. Equally, there could be trade deals between certain countries, so energy supply could be affected in a positive way if there's really good relations between a country, but equally it could be difficult if there's difficult political relations between a country. So it doesn't have to be war and conflict, it could just be political tensions regarding the prices and the deals that need to be struck between the two countries to share resources. Costs of exploitation and production can affect energy supply. If it is hard to exploit to get the energy, then it is going to be more expensive. Equally, if in order to make the energy usable, if that costs a lot of money, again that will drive up the cost of the energy to the country and the consumer. Physical factors affect energy supply. So this can include the shape of the land. So for example, hilly land may have more relief rainfall and it may be more suitable to put a dam and a hydroelectric power station, etc. So physical factors can affect the energy supply. Technology. HICs, high income countries, will have access to greater and better technology than some of the LICs, and therefore they will be able to develop better, more efficient energy supplies than other poorer countries. Climate also affects energy supply. If you are looking to have wind farms or solar farms, it is climate that will determine which type of energy is more suitable. Use the caboodle, use the factors that we've just discussed, and pause the tape now and try to complete the box as well as you can. Question 3. What are the reasons for growth in global energy consumption? So here we're asked to think about the economic developments as well as the rising population. It says in the responses, energy demand increases with development. Newly emerging economies account for 90% of the growth in demand by 2035. China has led Asia's energy demand, but it is slowing. India and other parts of Southeast Asia are industrialising. So as a country develops, its demand for energy also starts to spike. However, after a period of growth, it starts to slow down. However, by this point, other countries are starting to emerge and their own energy needs are increasing. The next part of the question is talking about rising population and technology. So if population is rising, then it makes sense that the need for energy is also going to rise at the same time. It says here, by 2050, the population will be 9 billion. Thus, energy consumption will increase. Computers and other electrical equipment, prosperity and better quality of life increases the use of vehicles, lighting and heating. So technology increases with the number of people, and as people are getting richer, their demand for products which require energy also goes up. Take a moment to pause the tape now to make sure that you've completed these boxes suitably. Okay, so here we're looking at the impacts of energy insecurity from pages 290 to 291 in the Caboodle book. And it talks about exploiting energy resources in the Arctic. This is a fact file. So you need to read the information about the Arctic and then answer these questions. How much does the region hold? What are the environmental consequences? What are the economic costs? And what are the environmental costs? Please pause the video here, go into Caboodle or to your revision guide and find out about the Arctic fact file, take some notes and come back and check your answers with ours. Pause now. Hi, welcome back. So let's take a little look. So the first question is about how much does the region hold? Well, it holds about 13% or 19 billion barrels of the world's undiscovered oil resources and 30% of natural gas. And what are the environmental consequences? Well, an oil spill could be catastrophic. It's a fragile environment in the Arctic. There are low temperatures, which means that ecosystems take a long time to recover. So it's really important that any energy that is extracted from this area is done so carefully with an environmental conscience. So what are the economic costs? People demand higher wages. Drilling equipment may sink during summer thaw. 8 countries currently lay claim to Arctic, causing political issues. So there are some economic costs in trying to extract that energy. And then obviously we've talked a little bit already about the environmental costs. Environmental controls are needed to prevent damage. Long distances to transport materials and the oil etc. from one place to another. And we need special equipment because of the extreme temperatures. So it's not very easy to transport and move material, and it has an environmental cost in doing so. Question 3 here asks why the use of biofuels have increased. So if we take a look at the response, it says in response to carbon dioxide emissions concerns, fossil fuels exhaustion and climate change and pollution. So we're looking at biofuels as an alternative to fossil fuels because we're concerned about them running out, as well as the carbon dioxide emissions. What is the impact of some countries suffering from poor electricity production? In some countries, they're experiencing power cuts, they're experiencing the closure of companies, and if you read in Caboodle, you'll be able to find out information about Pakistan, etc. And you'll be able to see and understand some of the impacts that poor electricity has on a country. A shortage of energy can lead to political conflict, and we're being asked why that might be. When one state owns a bigger share of energy resources, it can hold its customers to ransom, it can raise its prices, or even cut off supplies, Russia and Europe, regarding gas supplies, this can happen. It says here about the Middle East produces 40% of the world's gas and 56% of its oil. So wars in the Gulf and Iraq in the 1990s and 2000s were driven by the West's fears of a global oil shortage and rising prices. So if one country has energy, they kind of hold the better cards, and they can withhold that energy from other countries, and they can determine the prices that need to be paid for it. Pause the video here and make sure that you've got enough information written down in your spaces. Okay, let's move on. So in this section, we're going to start thinking about strategies to increase energy supply. And we've got two main options really for increasing energy supplies. We can either develop and increase the use of renewable energy, for example wind, solar, hydroelectric power, or we can exploit non-renewables such as gas, oil and the use of nuclear energy. You've got a table that you need to have drawn out, so if you haven't got this table already drawn out, pause the video now and draw it. If you have got a printed version of the resource booklet, then you need to take a moment to read page 292, and then you need to make notes on the following types of energy. We've got biomass, wind, HEP, tidal, geothermal, wave and solar. You need to make notes on how it works, and you need to think about, can it increase energy supplies? Pause the video now and draw the table and complete the boxes using page 292 of the geography book from Caboodle. Good luck. Hi and welcome back. So let's take a look at the first 4 types of renewable energy source. So the first one that we've got is biomass, which is dung and organic matter which is burned. Some plants are especially grown, for example sugarcane, to do this. It can be a bit controversial as it takes up food productive land, and it can be smoky and unhealthy. Wind is turbines. We've seen pictures of these in the previous videos, and they can be on land or they can be out to sea. And if you look back in the videos, we looked at Brighton, I think, as an example. It says there that 10% of the UK electricity demand has been met in 2014 by wind. However, they talk about NIMBYs. A NIMBY is someone that says, oh, I really like wind power, but then actually in reality doesn't want to see the wind turbines out their window. And NIMBY stands for not in my backyard. So they often support things in principle, but when somebody says actually we're now going to put a wind turbine near your home, they're like, oh no, not having that. It does have potential, particularly in the UK where we are surrounded by coast and we have the wind, which means that wind turbines could be quite successful. HEP, hydroelectric power, are large-scale or micro dams which create water movement to drive turbines, and those turbines create the electricity. However, large dams are really expensive and they're controversial. They require the flooding of land behind, so you have a dam between two mountains or something in a valley, and you have a dam between that, and then behind that you have to flood often hundreds of miles of land, which means that you're going to lose settlements, buildings, communities, you're going to lose ecosystems, etc. So they can be controversial in that example. Also, they require a lot of concrete, and that it has its own environmental impact. It currently creates 85% of global renewable energy, so HEP, hydroelectric dams, are important and they have produced a huge amount of electricity. Tidal energy. Turbines within barrages across estuaries, the tidal rises and the tidal falls creates the electricity. There aren't many of these in existence. They're really expensive to put in place, and there are environmental concerns about what they might do in those areas and in those estuaries. Take a moment to pause the video here and complete your table. Okay, let's look at the final part of the table. If you haven't already, pause the video and complete the second part of the table. However, if you have already completed the table, then let's take a look at your responses and what you wrote. So geothermal energy are the hot rocks underground which heat the water and create steam which can drive the turbines. This is a good way of using renewable energy. However, it's limited to your geographical location. You need to be in tectonically active regions. The United States of America has 77 geothermal plants. In Iceland, it accounts for 30% of the country's energy. So where it can work on those tectonic regions, it can work successfully. Looking at wave energy, the waves force air into a chamber that drives turbines that produce the electricity. Portugal is an example of a country that built one in 2008, but it's very expensive and does create environmental concerns. Many of these are experimental at the moment. And then solar energy, which requires the cells that are mounted onto solar panels, which convert sunlight into electricity. They're largely seasonal in some regions. Solar farms need a lot of space. They have great potential in some LICs, which have high levels of sunshine. But again, in HICs, we're seeing more and more solar farms in our areas. And again, you get those NIMBYs, not in my backyard. So people that don't want to see those solar farms near where they live. However, other people will be in favour of them. Let's move on. So question 3 is asking us to describe and suggest reasons for global variations in each of these different types of renewable energy production. So we need to think about global variations. So why different countries around the world can use different types of energy. So we've got wind energy, biomass energy, hydroelectricity and solar energy. If you haven't, pause the video now and go back to Caboodle and take a moment to look through and see if you can find the answers yourself and jot them down. However, hopefully you've already taken the time to complete the booklet, and if so, continue with the video and see if your answers and ours match at all. Okay, so wind energy depends on areas where the wind is going to be sufficient. So in some areas it will be unpopular because there may not be enough wind to sustain wind energy. The biomass energy, 500 million tonnes of oil equivalent in South America, but North America, Asia and Southeast Asia have 250. It's probably a more realistic option where the potential fuel supplies such as crops can be grown rapidly because you require that food production in order to make that energy. Let's take a look at hydroelectricity. So it says here that hydroelectricity is evenly distributed across the examples given in the maps and on the tables, etc. It's a high cost of dams might account for larger quantities in the USA, Europe and Northern Asia. Drier regions have fewer, for example Africa and Australia, and that makes sense, doesn't it? You require water for hydroelectric power and therefore some countries are going to have better access to that water and therefore better ability to make that hydroelectric power work, whereas in drier regions it would not be a suitable choice. Solar energy, it says there that there's more found at lower latitudes where there's a marked increase in sunshine, parts of India, China, etc. Okay, so solar energy tends to be in lower latitudes. We are now on pages 294 to 295 of the workbook, and we are being asked to think about what is natural gas. You are being asked to describe it and draw the 3 images with notes in the boxes below. So it says here, what is natural gas? And it says it's a hydrocarbon forming from the decomposition of organisms on the seabed millions of years ago. And then the 3 diagrams it's asked you to draw, I've had to do writing for mine, says sea plants and organisms buried on the ocean floor covered by sand 300 to 400 million years ago. That buried deeper pressure and heat turns them into oil and gas called hydrocarbons about 50 to 100 million years ago. And oil and gas found deep under the sand, silt and rock is happening today. So that shows the process of how that's been formed. The second question says, where is natural gas found? Use the map and table on pages 294 to help support your answer. So hopefully you've taken a look at the map and you can see that 60% of the world's gas reserves are found in Russia, Iran and Qatar. Russia produces most, 48 million metre cubed in 2015. China, USA, Mexico and Argentina have the largest shale gas deposits. The final question here is asking us to complete the table below to show the advantages and disadvantages of extracting natural gas. So the advantages are it's the cleanest of fossil fuels. There are fewer environmental risks than oil spills. Creates employment. It's transported by pipeline or tankers on land or sea. And it's fairly abundant. There's access to shale gas becoming more economically viable. However, disadvantages: it is dangerous if it is handled carelessly. Some countries with gas reserves are unstable politically and they could use it as a political weapon. It adds to global warming as it does release carbon dioxide and methane. Fracking requires a lot of water which is contaminated with chemicals and can cause earthquakes. Pause the video now and complete the table. Question 4 is about extracting natural gas in the Amazon. You're being asked to look at page 295 and then name of the project and the year and consider the advantages and disadvantages. So we're looking at 2004 and we're looking at the Kamizi project in Peru. The advantages are it saves energy costs in Peru up to 4 billion. They talk about making money over the next 30 years in gas exports. It's creating employment. It boosts local economies, which is a positive multiplier effect. It leads to improved infrastructure, which benefits the locals, and agriculture may also improve. However, as all things, there is a lot of disadvantages, for example, deforestation and the loss of habitats as the pipelines need to be created. Indigenous tribes in the region are going to be affected by any disturbance. There's going to be a change in their traditions and cultures as they come across other people and communities. And there could be damage to their water supplies which could be affected. Developers might think it might also bring in diseases from which the locals have no immunity. Routes have been cleared through the forest, which increases the risks of landslides, river pollution, sediment, and the decline of fish stocks, which again will affect the indigenous people to the region. If you haven't already, take a moment just to read through page 295 and find out a little bit more about the Kamizi project. Then pause the video and take some notes and make sure that you've got everything in place for this part of the booklet. This is the end of this session. In order to complete your booklet, you need to watch the final resource management video, which is coming up shortly. My name's Mrs. Wingham and you've been listening to Geography Rocks.